So welcome everyone to the lecture 19 of the course on data structure and algorithm. So far what we have did, that is number one, um, infix to fix conversion. Next we understood infix to prefix. Okay, then evaluation of postfix, then evaluation of prefix. Okay. So these are the main four topics, out of which we have covered one. Okay, we have understood its logic. So logic, Ben also understood its logic. Okay, also this logic, but this is not yet covered. So I think I can give you this as a context. Okay, so then what we have to do, algorithm analysis, complexity analysis. Complexity. So infix to postfix conversion complexity. Next, this is required. Complexity is still not done, and this is also not done. Complexity, all four. And I think you can do it also yourself. Complexity once you are done with the algorithm. So we have not done the algorithm development also. Okay. So many topics are there. Four topics. Algorithm. Also, it's algorithm. Okay, and this algorithm. So these are our agenda. Okay, what we have to study. Out of which we have only covered logic, this logic. Three. Okay. Earlierly, what we understood before this, stack. This is stack application. This is stack. Okay. In stack, we have done the logic. What is stack? Okay, logic using array in theory. Okay, logic, algorithm, and code implementation. Code implementation using array have been done in theory. Okay, and then you did logic. Okay, and code implementation using linked list in lab, right? And as you have to write in the lab record also, so you will do the complexity also. Complexity. Yes, on your own yourself. So this is our agenda. So please try to clarify what you are studying in the next uh, sessions. So this is stack application. Okay, fine. Okay, so this is our picture. Now the algorithm complexity analysis is not a big deal, because once you write the algorithm, it will be very easy to find out the complexity. Okay, so more or less, for example, I can share one topic on my lecture note, stack implementation. I will share the stack lecture note. Okay, from you can refer that note, from where you can have the idea of writing algorithm. I think already you have written the algorithm, because stack is already done in the lab. So just complexity analysis also you have done. So now as a cross check, you can refer to my lecture note. Yes. Okay. Now, okay. So today, what we are supposed to do, we are trying to study a different topic today, which is polynomial arithmetic. This is the application of single linked list. application of linked list. Okay, so yes, we are skipping few topics because it will take lot of time to cover all the things: infix to postfix, algorithm complexity, infix to prefix, algorithm complexity, evaluation of postfix, algorithm complexity, and evaluation of prefix, entire thing. So it will take a lot of time. I think you have understood the logic, implemented the code. Evaluation of one group has already implemented how to evaluate postfix. Okay, program code implementation, and today B2 will do the same evaluation of postfix expression, and that is your first assignment. And your second assignment will be infix to postfix or prefix conversion. Okay, so both the things, conversion, infix to postfix, infix to, all these four, you have to understand the logic, you have to write algorithm, you have to implement code, and also you have to analyze the complexity. Okay, all the four topics you have to cover. So make sure all the tick marks you are having. Acha. So I think you try with yourself. I think you can do. If one after 1 week we will come back to the discussion of these topics again. So what you have do, what you have not do, you have not done. Okay, so today our topic is polynomial arithmetic, which is an application of a linked list. Okay, so it is how many students are present over here? 41. It's a good health. Okay, it's 40. So 40 students present. So please try to put your concentration a bit more, because it is not a I mean, difficult topic, very easy topic, just a new topic which you require some bit concentration to understand. Okay, okay. So what we are supposed to do, that is, let's take two expression, algebraic expression. We are mean to hear polynomial arithmetic means it's an algebraic polynomial, right? So let's say we take one example, polynomial 1. Okay, polynomial 1, let's say uh, a square, okay, plus 3a plus 5. And then we are taking another polynomial, polynomial 2, and let's say there is a cube, then minus a square minus 2a. That's it. Okay, so how to evaluate this addition? If I want to perform addition operation on these two polynomials, polynomial 1 plus polynomial 2, how can I do that? So a square plus 3a plus 5. Next is you are not writing a cube just below a square. That is what important logic. Okay, you are writing here a cube, and then you are writing here minus a square, and then you are writing here minus 2a. Okay, that's it. Then what you are doing? So what is the logic behind this? Why are you rearranging the positions of the terms, right? Because these two are like terms. So you are vertically aligning the like terms. Okay, so this is important, right? Important logic. So a square, then what you are doing, you are supposed to write here a square, you're supposed to write here a cube, you're supposed to write here a, and here something. Now every term, okay, let's say 3a, So this is a term in a polynomial. So it consists of two parts. One is a constant part or coefficient,
Constant and the variable.
right? And another is the variable part, right? So you write the variable part immediately after this, right? A cube, a square, a. And in this case, a to the power 0. If you are not writing anything, means a to the power 0 means 1 actually. That means 1. Okay. So this 3 and a are written side by side. What does that mean? Actually, 3 dot a means 3 and a are multiplied. So this is a product term. Product of 3 and a. Product of coefficient of variable part. Okay. So yes. Okay. Dot is there. Means multiplication is there. And one dot is there. Right. Now we are here to find out the resultant coefficient value. So above it, nothing is there. Means if you virtually write here a cube, not a problem, but its coefficient must be equal to 0 to ensure that this term is not present over there. Okay, and here no sign is there means by default it's a plus sign, and here also no sign, you can write here 0. 0 into 1, ultimately it is a 0. Okay. Okay. So you can complete this whole thing. I mean, uh, the while performing the addition, the maximum length of the resultant polynomial, this is the resultant polynomial, will be equal to 4. Length means the number of terms in the polynomial will be equal to 4. Though the number of terms in the polynomial 1 is 3, though the number of polynomial terms in the polynomial 2 is 3, so apparently it will look like what will be the number of terms in the resultant? It is not 3, it is 4. So why is that so? So that is another important logic. Okay. So the 4 means you can simply calculate the number of terms in the resultant polynomial like this. So what is the degree of maximum degree of the polynomial? In this case, the degree of the polynomial 1 is 2. In this case, the degree of the polynomial 2 is 3. Okay, so if when find the max of these two degrees, okay, so you are getting max equal to 3, right? So the maximum degree present in either of the polynomial is 3. So immediately you count the number of zeros, a number of terms from 0 to starting from 0 to ending with 3. So total 4. 0 to 3, 4. So that is the generalization of the logic to find out the number of terms in the resultant polynomial. Okay, so maximum degree plus 1. That will give us the number of terms in the resultant polynomial. So you must start with term with power index equal to 0. These are called actually indices, index or power. Mathematically it is known as index. Okay, and now as we know, we are using index term in our programming in a different manner. Okay, so okay, we will call it as a degree or power. So degree of this term is 3, not degree. Degree means something else. Degree means an overall thing, overall property of a polynomial. Okay, so let's call it power. So power, highest power is here. কি বলছিলাম? Sorry. So here you write the power of the term 0 here, power equal to 1, power equal to 2, power equal to 3. So start with power equal to 0 from the right end, end up with power equal to 3 in the left end. Okay, in this manner, the power is increasing. Okay, so after knowing the number of terms in the resultant, then after writing the variable terms with the power starting from 0 to 3 in this case, okay, if the number of terms is equal to n, the maximum degree of the resultant polynomial will be n minus 1. So you know the powers starting from 0 to n minus 1. That is the generalization, 0 to n minus 1, a to the power 0 to a to the power n minus 1. So after writing this variable terms, then your focus will be on finding the coefficients of all these terms. So what to find the coefficients? Here the coefficient is 0 and here it is 1. 0 plus 1, 1. Next, here it is plus 1, include the sign also. So here plus 1 and here minus 1. So 1 minus 1, 0. You can here give a plus sign and put a 0. Coefficient is 0. Resultant coefficient of a square term is 0. Next, plus. I don't know what will be plus or minus, I don't know, but by default I am writing minus, plus. So here the coefficient of a is 3a in the polynomial 1, here it is minus 2. So 3 minus 2 plus 1. So, and then plus 5 plus 0, as a result plus 5. So it is looking like 1a cube plus 0a square plus a plus 5. So that is your result. Okay, so for study purpose, we can simply display this much. 1a square, okay, plus 0a square, 1a cube plus 0a square plus 1a plus 5. Okay, no need to write here dot 1 because this is not a variable, it's a constant term, so you can easily compute the addition, subtraction, whatever of constants very easily, right? So 1a cube plus 0a square plus 1a, it is not convenient to, it's not 1a, right, 1a cube plus 0a square plus 1a plus 5. So this is your result. If you display this result, it will be fine for us for study purpose. And then you can also further modify your program so that it will be displayed only in this manner: a cube, okay, plus a plus 5. So that is a different issue. That is not our motive as of now. You can do it later also, but up to this, if we can display, that is enough. Okay, so how to do this in computer, how to write a program, okay, to get this answer from the computer in this manner. Okay, so linked list will help us in this regard. So let's try to understand. Consider a polynomial in general: a0 x to the power n plus a1 x to the power n minus 1 plus a2 x to the power n minus 2 plus dot 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 plus an minus 1x plus an. So it's a polynomial of degree n, okay, and number of terms equal to n plus 1. So here this is the constant term. Here an is multiplied with x to the power 0. This term corresponds to power of x equal to 0. This term corresponds to power of x equal to n. 0 to n, total n plus 1 number of terms in the polynomial with constant term n. So each term consists of a coefficient part ak and exponent n minus k. So please try to focus on the notation of the term, which this will be used in the algorithm development. So ak, okay, you understand the suffix, okay, superscript k. So and exponent n minus k. So see, so this is a0. If the superscript is 0, then the power will be n minus 0, n. If here superscript is 1, then the power will be n minus 1. If here 2, then n minus 2. Like that, here it is n minus 1. So it is n minus, in bracket, n minus 1. So ultimately it is 1. Here it is an, superscript is n, so power x to the power n minus n, that is 0. That's why if you have a coefficient part ak, you know that the power of that variable term will be n minus k. That is the relation. So an array of structure can be used to represent the polynomial where each term is represented by structure. So this structure is nothing but consisting of a coefficient part, it may be a real value, and exponent part. Okay, so okay, shortly coming. Why? Shortly coming. So struct term. Each term is a, we are treating, considering each term as a structure. and the structure is consisting of two parts, coefficient and exponent. So int coefficient, int exp. Okay, you can take also coefficient as a float, no problem. Okay, so for simplicity we have taken int, but power, in polynomial you're supposed to have integer powers. We are not, so we will not complicate our theory here, because I mean, polynomial with uh, I mean non-integral powers is not in our context, so we will restrict ourselves to have to assume to consider integral powers only, integral exponents. But yes, you can take integral or float coefficients, no problem. So that's why it will be a structure. Okay, so these two components will be combined together into a single entity, that is your structure. Okay, then so how it will look like this single term C. So let's take an example, 2x to the power 9 plus x to the power 7, like this. This is one example of a polynomial of degree 9. Now if I want to represent this in a linked list, it will look like this. Oh, sorry. Now if we represent this, what it is, this is a linked list or what? Oh, it's a link, yeah. It's a array, but see, this is one visualization. So two-dimensional array. Okay, so this outer border, these outer borders, how many outer cells are there? 1, 2, 3, 4, 5, 6, 7. Okay, so 7, yeah, it is 7. Okay, because there are 7 terms, 1, 2, 3, 4, 5, 6, 7, 7 terms are there. So to store 7 terms, you require 7 cells. Okay, so I mean an array of 7 elements have been used, okay, to store the terms, each term, right? 7 terms, and in each term you have two parts, coefficient and exponent. So each of the cell of the 1D array of size 7 will be of another one-dimensional array, which is containing two elements. One element will store the coefficient, other element will store the exponent. Okay, so this is that zeroth one-dimensional array. Okay, inside the zeroth cell, the first part is containing the coefficient of the first term, and the second element, next element, this element is storing the exponent of the first term. Okay, similarly 1 7 is stored over here, 2 6, 3 5, 4 4, 5 2, and 1 0. Now if we consider another polynomial of 5 terms, okay, it can be simply stored like this in a two-dimensional array. Okay, so t0, t1, t2, t3, t4. So this is t0, this is t1, this is t1, t2, t3, t4. So 1 4, 1 3, 1 2, 1 1, 2 0. Okay, fine.
So
Now,
last one 2 0.
yes, 2 0. Yes,
2 is the coefficient, 0th is the power, it becomes 1 to.
2 into 1, 1, 2.
না না পাওয়ারটা 0 তো
Power to 0.
তো 2 to the power 0
x to the power 0.
x to the power
তো
0.
1
to the power 0, হ্যাঁ
তা তো 1 হয়ে যাচ্ছে
x to the power
1 ই
0
তো
into
হচ্ছে।
2 equals
x to the power 0 into 2.
2
2 into 1.
2 ই তো হচ্ছে।
আচ্ছা আচ্ছা ওকে ঠিক আছে ঠিক আছে
This is not 2 to the power 9. This is the coefficient part.
হুম
This is the power of the x.
ঠিক আছে ঠিক আছে।
Okay. Okay. So you got the visualization, how it will look like. Now we have here we have considered structure to represent a single term of a polynomial, and you need several structures of similar type, right? Because they are terms, so their definition is same. Okay, so what you require an array of structures. Okay, array of structures. Array of structure means an array of which components, elements will be structures. And what are structures? Terms. So that means you are taking an array of terms of the polynomial. Okay, so for example, this is like an array, and inside which this is not actually an array. Okay, looking like the outer border is actually the array, the inner border is actually the structure. So this is the zeroth structure of this entire 1D array of 7 sides. This is the first structure, second structure, third structure, fourth structure, fifth structure, sixth structure. And what is a single structure? A single structure is nothing but a term. And why we are complicating this? We are not unnecessarily complicating the things, because if your coefficient is float and the exponent is integer, you can't take a 2D array, because in array the elements must have similar data type. Okay, so that's why, to generalize a little bit the thing, we have taken each term as a structure. We have to take it as a structure. Okay, so these are structures, and all those structures which are nothing but terms we are storing inside a single array, and that is very easy to understand and very easy to implement. Array of structure can be implemented, memory allocation can be done using a single line of code: struct term t10. Okay, so what is a structure definition? Data type struct term. So data type is struct term, like int x in bracket 5, that is a integer array, right? Int x, int x in bracket, if you write 5, so what does that mean? This is the general syntax. How do we declare an integer array? So this is the data type, this is the name of the array, and this is the size of the array, right? So here you have to name the array of the name the array. So for example, the name of the array is t, and the size is, for example, 10. You can do dynamic memory allocation, but we are not complicating thing here. This is very new topic, and I recommend understanding of the topic is very important, rather than doing hi-fi things. Okay, so once we complete the basic thing, we will next actually upgrade our program, incorporating dynamic memory allocations, pointers, etc., etc. Okay, so this is the name of the array t, and this is the size of the array. Okay, for example, we can take maximum 10 terms to store in a polynomial. Okay, so maximum 10 terms we will accommodate, not more than that. Okay, for example, you may take 20, and then here the data type. So what is the data type of the array element, right? How to define the data type of the array? So what will be the contents of the x? The contents of the x are integer values. That's why the data type is integer. Okay, but here what are the elements you are storing inside this array? The elements are nothing but terms. And what are the terms? Those are nothing but structures. So what are the data type of this structure? Struct term. Immediately you are writing here struct term. So this is how we are initializing, declaring an array of structure in this case. Okay, so this will do your memory allocation. A blank memory allocation will be done after the name t with the size 10, where you can accommodate 10 terms maximum, and those terms will have the definition this: int coefficient, int exponent. Okay, so struct term t10. Next, int term number. Okay, so this is another information we want to have inside a polynomial. So polynomial, this entire thing, then this entire thing, one dimensional array, along with this term number, entire thing becomes another structure, and that structure name is polynomial. Okay, and this is the structure definition: struct term t. So the first line, this line means this one dimensional array, and along with int term number. Okay, so together it is defining the structure of a polynomial. Okay, now polynomial 1 point, oh, it's been clipped
স্যার
a bit. হ্যাঁ বলো।
স্যার বলছি টার্ম নাম্বারটা কি অ্যারের ইন্ডেক্স গুলো?
হ্যাঁ বলে দিচ্ছি, এখানে বলে দিচ্ছি টার্ম নম্বর।
ওকে ওকে।
Yeah. So it's little bit clipped, but I will dictate. So polynomial 1, polynomial 2. What you have to do, understand here. So how many terms in the polynomial 1? Let's say in 1. So this is the generalized algorithm we are here trying to understand. So number of terms in polynomial 1 in 1. This is polynomial 2. So number of terms in polynomial 2 is n2, for example. You assume this. Now, these are actually notations which we will use in the algorithm. That's why. So each term in first polynomial is represented by T1. T1 for 1 for no polynomial 1. Similarly, for polynomial 2, it will be T2. Okay. So now, which term of polynomial 1 to represent that? This is written T1I. I means ith term of polynomial 1. Similarly, T2J means jth term of polynomial 2. Okay. So each term of polynomial 1 and 2 are represented by this notation T1I and T2J respectively. And each yes, okay, each T1
আচ্ছা আচ্ছা স্যার স্যার জাস্ট ওয়ান থিং স্যার যদি স্যার তাহলে যদি ফার্স্ট টার্ম হয় তাহলে স্যার T11 হবে তাহলে যদি ফার্স্ট
T11.
টার্মের জন্য
For in our case, for layman understanding, it should be T11. Okay.
আচ্ছা
Okay. So, but yes, in program perspective, you may have to start with index 0. That's up to you. Okay. So T1I. So each T1I will consist of two components. One is the coefficient and the other is the exponent. Okay. So coefficient is represented by small c1i and exponential part is exp1i. We are not using e because e means something else, a constant. So exp1i, 1i. Okay. For one caution, that is in programming, if you already have a built-in function as exp in math.h header library, so use some other variable name. Okay, so this is just for your understanding purpose. So c1i exp1i, and here we are using the index as I as index variable. Similarly, in polynomial 2, T2J will have two components, C2J and exp2J, where J is the index variable. Okay, and now in resultant polynomial, the number of terms will be what? The max of n1 plus n2, n1 and n2. That is the number of terms, and it is equal to. It should be nr. The number of terms in the resultant polynomial equal to max of n1 comma n2 equal to, it is missing here, clipped, that is actually nr, capital N, capital R in superscript. Okay. So each term we are representing by small t, capital R means resultant polynomial, and the index variable is small r. So TRR is consisting of two components, C capital R smaller, exp capital R smaller, where smaller is the index variable. Okay. So now coming to the algorithm. Okay. Initialize TRR equal to 0. Resultant polynomial. So you will you know how many terms you have to compute for, right? So that will be the size of the resultant, size of the array. Okay, so this is the array corresponding to polynomial 1, this is the array corresponding to polynomial 2. So to store resultant polynomial, you require another array. So you do memory allocate of another array to store the terms of the resultant polynomial, and how many terms you have to store, that is here. So based on that, you can later on modify your program to incorporate dynamic memory allocation, because you know every time the number of terms will be changing, and accordingly using dynamic memory allocation you can allocate the memory for the third array to store the resultant polynomial, right? So initialize, so you have a blank array to store the third polynomial, resultant polynomial, and you initialize TRR equal to 0 for all small r in capital R. Okay. Next, nr is equal to max of n1 comma n2. Okay. So next, I equal to 0, j equal to 0 for r equal to 0 to nr in steps of 1. Okay, so see, we are starting index from 0 and ending with nr, because yes, 0 to nr in steps of 1. So for program perspective, you may just tally this, whether you have to include or exclude either of the variable, either of the constant value. Okay, 0 or nr. So r equal to 0 to nr in steps of 1. Do what? Okay, if the exponent of 1I, first polynomial, is greater than equal to the exponent of the second polynomial, what will happen? For example, here x to the power 9, the exponent is 9, and here exponent is 4. Exponent is 4. Okay, so 9 is greater than equal to 4, satisfied. So what should you do if the exponent is higher than this, 9 greater than 4? কি করবে তুমি? Your logic is you can't add this term and this term because they are not like terms. Like term means their exponents must be equal. So you can add those terms of which exponents are same, equal. And if they are not same, you can't perform any addition, subtraction, whatever.
Yes.
So this is important. So if exp 1i greater than equal to exp 2j, then what should you do? You check if exp 1i is equal to exp 2j. Okay, greater than equal to means either exp 1i is greater than exp 2j or exp 1i is equal to exp 2j. Both the thing are possible. ঠিক আছে, 9 greater than equal to 4 স্যাটিসফাই হয়েছে, তো 9 4 এর থেকে বড় হতে পারে, 9 4 এর সাথে ইকুয়াল হতে পারে, দুটোই তো হতে পারে, তো কোনটা হচ্ছে? সো ফার্দার চেকিং উই আর ডুইং। সো ইফ exp 1i is equal to exp 2j, then only you can perform the addition because they are like terms. So addition means addition of their corresponding coefficients. Okay, so for example, due to this if condition, second nested if condition will be satisfied when this 4x to the power 4 and x to the power 4, these two terms are encountered because their exponents are same. What will happen? See, 4 greater than equal to 4 satisfied. Further if condition, is 4 equal to 4? Yes. So what will happen? Their coefficients, here the coefficient is 4, here the coefficient is 1, they will be simply added. 4 plus 1 equal to 5. Okay, so C1i plus C2j, their coefficients are being added and is stored into the corresponding coefficient in the resultant polynomial, C capital R small. That's easy, very easy, right? And then the corresponding exponent will become the same exponent, exp1i or exp2j, right? So in this case, you have constructed the resultant term corresponding to this 4x to the power 4, x to the power 4. Their exponents are same. You are adding their coefficients. 4 plus 1, that is 5. 5 is stored in the corresponding coefficient term, CRR. And what will be the corresponding exponent? Exponent will be simply 4. They are equal. So expRR equal to 4. 4 means either exp1i or exp2j because both are same. Okay, and then you do I plus plus j plus plus. I mean, going to the next term. What if this if condition is false? For example, this 9 is this term and this term is compared to x to the power 9 and x to the power 4. So their exponents are not same. So 9 greater than 4. So this outer if condition is true, but the inner if condition is false. So if this if is false, it will come to else part. What you have to do? What you will do? If 2x to the power 9 and x to the power 4 is being compared for the first time, and if you find that 9 is greater than 4, if this if is false, that means what? 9 is greater than 4, no chance of equality. So 9 is greater than 4. What shall you do? কি করবে তুমি?
স্যার পরের টার্মে যাব তাহলে, মানে
পরের term
টু টু দি পাওয়ার x টু দি পাওয়ার 9 থেকে x টু দি পাওয়ার 7 এ যাব।
That is the slight mistake, very slight mistake. So see, go very do it slow. 2x to the power 9, okay, and you are comparing it with x to the power 4, okay. If this, and this is the maximum, I mean term corresponding to highest degree, highest power, and this is the term corresponding to highest power, right? So there is no chance or no possibility that in this polynomial you will have a term with exponent more than 4, because you have started comparison from this term and this term, right? ঠিক আছে?
So we have to find via loop in the first polynomial where we can find the power 4.
No, it's just about taking a decision at this moment. You have found
এখানে
that
4 ম্যাক্সিমাম মানে তো বাকি ওখানে আর থাকবেই না।
no, you are too much hurry. প্রচুর জলদি করছো। আমরা কি করলাম এখন? আমরা ভেরি কনসেন্ট্রেট করো। 2x to the power 9, এখান থেকে কম্পারিজনটা স্টার্ট হয়েছে। x to the power 4 এখান থেকে কম্পারিজনটা স্টার্ট হয়েছে। সো 2x to the power 9 আর x to the power 4 কম্পেয়ার হচ্ছে। So they are being compared. After comparison, you have found an information that the exponent 9 is greater than 4. There is no chance of equality because this if condition is false. So now you have to take a decision. What will you do? 9 greater than 4. It's a time for taking an action.
স্যার আমরা ফার্স্ট পলিনোমিয়ালটার মানে রাইট সাইডে আমরা শিফট করতে
সেই হিসেবে
থাকবো
হবে।
যতক্ষণ আমরা এই সেম নিচের পলিনোমিয়াল মানে ডিগ্রিটা আসছে নাকি, এক্সপোনেন্ট যতক্ষণ সেম না হচ্ছে, till we reach the corresponding exponent of the second polynomial.
একটু তো বলেছিলাম
স্যার 9 থেকে 5 অবধি অ্যাড করব, তারপর শিফট করে যাবো ওরা ওয়ান সাইড রাইট প্লেস ফার্স্ট পলিনোমিয়ালটা।
হ্যাঁ স্যার এটাই বলছিলাম।
This will be already a constructed term in the resultant polynomial.
রেজাল্টেন্ট পলিনোমিয়াল এটা প্রিন্ট হয়ে যাবে তো অটোমেটিক্যালি।
হ্যাঁ স্যার এটাই বলছি,
হ্যাঁ,
9 থেকে
সেটাই
5
বলছিলাম।
অবধি।
তারপরে
যতক্ষণ না যাবো একটা লুপ নিয়ে কি দরকার? কি বলছো তোমরা?
না স্যার 5 অবধি।
9 greater than 4. That means this term is not possible to have a like term in the second polynomial. So this term will be simply copied into the resultant polynomial storage.
Yes sir, yes sir.
ইয়েস হ্যাঁ।
I can't understand why you are going for a loop and reaching where দীঘা মন্দারমণি কোথায় যাবে কি জানে, দরকার নেই ওটা। So সেজন্য বললাম যে this is the thing ki when you are facing this situation and you have found an information 9 greater than 4, that means and barbar hint dicchi na je you have to take a decision. You have got a very good information, now it's about taking a decision. What is that? So this will be the term in the resultant, that's all. Okay, so see, so term in the, that means you have to copy entire thing, means copy means its coefficient will be copied into the corresponding position of the resultant polynomial array, and the exponent will be also copied. ঠিক আছে, দেখো, so c coefficient crr is equal to c1i. Why c1i? Because that coefficient corresponds to the higher power, and exp rr equal to exp 1i, because exp 1i is greater than exp 2j, that's why. And then what? This is very important.
স্যার একটা
This I plus plus G plus plus is important now to understand, and this only I plus plus is very important. মানে কেন এখানে I plus plus J plus plus দুটোই হলো আর এখানে কেন শুধু I plus plus হলো, এবার বোঝার টাইম চলে এসেছে। তো তোমার এখানে এক্সাম্পলটা কি ছিল যে 2 to the power 2x to the power 9 and x to the power 4. So these two terms are compared. After comparison you have found that 9 greater than 4. That means this 2x to the power 9 will be the final resultant term in the resultant polynomial. Okay, so now you have to move on to the next term in polynomial 1 only. So you have to go to the next term, that is x to the power 7, but you have to remain at the same position x to the power
Yes
4.
sir.
Yes
স্যার
sir.
বলছি এটা তো অর্ডারেই থাকতে হবে তাই না?
And here index is j, that's why you are doing only I plus plus. So here we are doing only I plus plus. But earlierly, in this case, now you are in a position to understand why you are doing both I++ and J++, because this is something a situation when 4x to the power 4 and h to the power 4 will be compared. Their exponents are same. So
I প্লাস প্লাস করেই যেতে হবে আনটিল দ্যার পাওয়ার ম্যাচেস,
no.
মানে
Again, wrong.
দুজনে লাইক টার্ম হতে।
No, যত আমরা মুভ করে করে যাচ্ছি, যতক্ষণ না আমরা এটা পাচ্ছি, এরকম টাইপের কোনো কনসেপ্টই এখানে নেই।
আচ্ছা,
আমরা প্রত্যেকটা কম্পারিজনের পর একটা করে শিফট করছি, মানে পরে নেক্সট টার্মে যাচ্ছি।
নেক্সট টার্মে গিয়ে ওটা যদি আমরা প্রিন্ট করে দেবো।
যেতে থাকছি তা নয়, কিন্তু একটা টার্মে জাস্ট নেক্সট টার্মে যাচ্ছি শুধু।
স্যার বলছি ইউজার যদি কনজিকিউটিভ ওয়েতে না দেয় অর্ডার গুলো, তাহলে
হ্যাঁ,
যদি স্যার মানে আমি লক্ষ্য করছি এখানে প্রত্যেকটা অর্ডারে আছে, মানে 0 1 2 3
আচ্ছা,
4, যদি এরকম অর্ডারে না থাকে।
মেক ইট ভেরি ক্লিয়ার নাও। আমরা অন্য কোনো এই মুহূর্তে যে কনসিডার সিচুয়েশনটা আমাদেরকে ফেস করতে হচ্ছে, দিস ইজ দ্য সিচুয়েশন, point 2 polynomials are given. So let's understand this situation well, then other situation we can handle, not a problem, because we are middle of the algorithm understanding,
Okay.
not completed. Okay, otherwise প্রচুর কনফিউশন চলে আসবে। সো এই ইফ কন্ডিশনটা তখনই অ্যাক্টিভেট হচ্ছে ভেতরে, ইফ কন্ডিশনটা যখন 4x to the power 4 and x to the power 4 are being compared, their exponents are same. মোস্তফা স্যারকে একটু গ্রুপে বলে দিও তো কেউ, যে 5 মিনিট দেরি হতে পারে। আচ্ছা, 4x to the power 4 and x to the power 4, so exponents are equal. Then you are adding the coefficients, 4 plus 1, that is 5. 5 you are storing in the resultant coefficient, and the common exponents you are storing in the resultant coefficient. Then what is your job? From 4x to the power 4, this is done. X to the power, it is also done. So now you have to go to the next term only, that is 5x square, so I++. And similarly, as x to the power 4 is done, so you have to go to the next term in the polynomial 2, that is x cube. That's why both I++ and J++ you have done, and here only I++. Just এইটুকুই, এইটা বুঝতে পারলে এবার?
ইয়েস স্যার, ইয়েস।
এই যে একবার 9 greater than 4, মানে এখানে কোন একটা পাওয়ার যদি এখানে কোন একটা পাওয়ার থেকে বেশি হয়, স্ট্রিক্টলি গ্রেটার দেন হয়, তাহলে এই ইফ কন্ডিশনটা স্যাটিসফাই করবে, এই ইফটা করবে না, এই এলসটা করবে। আর যখন দুজনের পাওয়ার সেম, তখন আউটার ইফ কন্ডিশন উইল বি স্যাটিসফাইড, ইনার ইফ কন্ডিশন উইল বি স্যাটিসফাইড। তাহলে দুটো ভেরিফাই হয়ে গেল। এবার আরেকটা পসিবিলিটি হচ্ছে, when this outer if condition will be false, that means exp1i is less than exp2j, that condition will be true. সেটা তোমরা নিজেরাই করতে পারবে। দেখো, see, else part, this is else do means this else corresponds to this outer if. So this else is activated only when exp1i is less than exp2j. So do we have any other situation like this? Yes. Yes, when 5x square and 3 and this x cube will be compared, exponent is 2 and this exponent is 3. So 2 less than 3. So this comes under else part. Okay, so in this case there is no possibility that you will find a like term. So this is the if condition where you can find like terms only in the algorithm. Okay, because if like term means exponents are equal. Okay, so this else means exponent 1 is greater than exponent 2. This else means exponent 1 is less than exponent 2, and this if means exponent 1 is equal to exponent 2. And these are the only three possibilities while comparing two values, greater than, less than, equal to. ইকুয়াল টু কন্ডিশনটাতেই তোমরা লাইক টার্মস পাও, আর সেইখানেই একমাত্র অ্যাডিশনটা হবে, আর বাকিগুলোতে অ্যাডিশন হবে না। তো দিস ইজ এক্সপোনেন্ট 1, দিস ইজ এক্সপোনেন্ট 1 গ্রেটার দেন এক্সপোনেন্ট 2, ওটা হয়ে গেছে। দিস ইজ এক্সপোনেন্ট 1 লেস দেন এক্সপোনেন্ট 2, দ্যাট মিনস কি ছিল 5x স্কোয়ার, সো 5x স্কোয়ার অ্যান্ড x কিউব। ওকে, সো দিস পাওয়ার ইজ হায়ার। কি করবে? You will remain in this position because this is not yet done, but this is done. Why this is done? Because this will be simply copied into the resultant polynomial, right?
j plus plus করব।
Yes, CRR equal to C2j, EXPRR equal to
Yes,
EXP2j.
J plus, হ্যাঁ হ্যাঁ।
Yeah. Only you are moving in the next term in the polynomial 2 only, but you are remaining in the polynomial, and that's it. Very easy logic. Logic is very easy, and algorithm, you see, it's not a big deal. It's very easy to understand the algorithm. Only it's about proper notations. And two important new topic is introduced here in terms of programming skill, that is array of structure. And the code is very very easy to write, right? It's not a complicated thing, but yes, the concept is little bit new. Okay, array of structure. ব্যাস হয়ে গেল। এইটা হচ্ছে অ্যালগরিদম। এই অ্যালগরিদমটা দেখে দেখে এবার তোমাদেরকে কি করতে হবে, প্রোগ্রাম ইমপ্লিমেন্টেশন করতে হবে, এন্ড ইটস নট আ বিগ ডিল। তো এইটা পুরোপুরি আমরা নোটেশন ওয়াইজ করেছি। এবার এটাকে আমরা লিঙ্ক লিস্ট দিয়ে করব। লিঙ্ক লিস্ট মানে লিঙ্ক লিস্ট কেন, এই এক একটা টার্ম হচ্ছে অ্যাকচুয়ালি স্ট্রাকচার, ঠিক আছে? সরি, এটা কি বললাম, লিঙ্ক লিস্ট না? তো লিঙ্ক লিস্ট না দিয়ে করতে পারো, মানে আলটিমেটলি আমরা করবো ল্যাবের মধ্যে। কিন্তু এখানে আমরা কি করেছি, অ্যারে অফ স্ট্রাকচার নিয়েছি বোঝার সুবিধার জন্য, যে প্রত্যেকটা এগুলো হচ্ছে এক একটা স্ট্রাকচার, আর স্ট্রাকচারগুলো এক একটা অ্যারের ভেতরে রয়েছে, অ্যারে এলিমেন্ট হিসেবে রয়েছে, সেই জন্য একটা অ্যারে স্ট্রাকচার হলো, অ্যারে অফ স্ট্রাকচার হলো। তুমি যদি এটা লিঙ্ক লিস্ট নাও তাহলে এই ঝামেলাটা থাকবে না, কেন কি তোমরা অলরেডি লিঙ্ক লিস্ট করেছো। তাহলে এগুলো এক একটা নোড হিসেবে ধরে নাও, স্ট্রাকচার মানে এক একটা নোড। তো one node is actually storing one term of a polynomial, and you are connecting the nodes, means you are connecting the terms, okay, from left end to right end in descending order of powers. Okay, highest power in the left end, first node of the linked list, and the constant term will be the last term of the linked list. Then it will be quite easier, I think, if you use linked list, whatever. So you try with both array, this concept already you implement, and then you switch to linked list. I think it will be good.
Okay, sir.
Okay, so I hope all of you have understood.
আচ্ছা আচ্ছা স্যার, একটা আজকাল একটা ডাউট ছিল, জাস্ট একটা সিম্পল একটা ডাউট ছিল স্যার। একবার একটু উপরের দিকটাতে একটু স্লাইড করবেন একবার। ব্যাস 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 স্যার। স্যার আরেকটু জাস্ট ইয়েস 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 স্যার। স্যার এখানে যে আমরা যে সেকেন্ড যে মানে স্যার যখন exp 1i is greater than equals to exp 2j, so sir we are entering into the exp 1i double equals to exp 2j, right?
Yes.
আচ্ছা, ওখানে স্যার সিম্পল যখন তখন স্যার মানে কোএফিসিয়েন্টস গুলো অ্যাডিশন করছি, তারপর স্যার যে নেক্সট লাইন exp rr equals to exp 1i, এটা তো স্যার আমরা exp rr equals to exp 2j ও লিখতে পারি।
হ্যাঁ করতে পারি, কারণ ইয়েস দুজনের সমান।
আচ্ছা আচ্ছা, ওইটাই স্যার একটা ছিল।
হ্যাঁ, এই একজনকে জিজ্ঞেস করলে যে কি একটা, তখন আমি বলে দিলাম যে আগে এই সিচুয়েশনটা ফেস করো, তারপর তোমার অন্য সিচুয়েশন।
স্যার আমি স্যার
বলো।
স্যার আমি বলছিলাম একটু উপরে নিয়ে যান, অ্যারেড মানে যেখানে পলিনোমিয়াল গুলো আছে। হ্যাঁ স্যার। স্যার এখানে দেখছি যে প্রত্যেকটা এক্সপোনেনশিয়াল গুলো সর্টেড আছে, মানে 0 থেকে ক্রমশ বাড়ছে। তো এই যে কন্ডিশনটা, এটা যদি অন্য রকম ভাবে হয়, যদি 1 to the power 3 টা আগে থাকে, তাহলে তো আমরা আরেকবারও চেক করতে পারি।
No, that is not a big deal, because whenever you store the polynomial into a linked list or this kind of a data structure, okay, so okay, for 5 terms 10 terms, তো আমরা মানে মানুষ বলতে মানে we human being, we used to write polynomials in descending order of powers. আমরা এইভাবে লিখি, ঠিক আছে, যখনই আমরা লিখছি। তো যেভাবে আমরা লিখছি সেটা আমার মনে হয় কনভিনিয়েন্ট হবে যখন তুমি ইউজারকে বলবে যে তুমি পলিনোমিয়াল অ্যাড করো, মানে এন্টার করো। তো পলিনোমিয়াল এন্টার করো মানে কিভাবে এন্টার করবে, কোএফিসিয়েন্টস দেবে, পাওয়ার দেবে, ঠিক আছে?
আচ্ছা আচ্ছা।
তো কোএফিসিয়েন্ট পাওয়ার দেবে, ওইভাবেই সাজিয়ে দেবে, কারণ আমাদের কাছে পলিনোমিয়ালটা শর্টেড অবস্থাতেই রয়েছে, তো আমরা শর্টেড অবস্থাতেই করবো। আর
আমি বলছিলাম যদি 1 4 এর জায়গায় 1 3 থাকে, তাহলে আমরা 1 3 টাকে চেক করেই রেখে দিচ্ছি, আর এটা মেনে নিচ্ছি যে আর কোনো মানে এক্সপোনেনশিয়াল 4 এর সমান আমরা পাবো না।
শর্টেড আছে মানে 9 আর 4 যদি কম্পেয়ার করো, 9 যদি গ্রেটার দেন 4 হয়, তো 4 এর আগে যে 5 6 নেই, এটা তো শিওর হয়ে গেলে।
হ্যাঁ হ্যাঁ, ওটাই বলছিলাম।
সেই জন্য ইউজার থেকে শর্টেড ভাবেই তুমি পেয়ে যাচ্ছ ইনপুটটা।
আচ্ছা, বুঝতে পেরেছি স্যার।
কোএফিসিয়েন্ট জানি হোক, পাওয়ারস গুলো তুমি শর্টেড ভাবে পেয়ে যাচ্ছ, ডিসেন্ডিং।
ইয়েস ইয়েস।
স্যার বলছিলাম যে স্যার রেজাল্টেন্ট পলিনোমিয়ালের যে মানে রেজাল্টেন্ট পলিনোমিয়ালটা স্যার nr ইজ ইকুয়াল টু ম্যাক্স অফ n1, n2 লিখেছেন আপনি, তো স্যার ওটা +1 হবে না লাস্টে একটা? তো আপনি যখন
দুটো সমান হয় তখন হয় না?
না স্যার, বলছিলাম যে স্যার স্যার আরেকটা উইন্ডোতে যখন দেখালেন, তো
ওটাতে দুটোই 3 ছিল, ওই জন্য +1 করেছে।
নাম্বার অফ টার্মস তো সেম নয় এখানে, n1 আর n2, ওই জন্যই বললাম।
ওখানে স্যার বোধহয় ওখানে মানে নাম্বার অফ টার্ম সেম ছিল, কিন্তু ওই পাওয়ার গুলো আলাদা ছিল, ওই জন্য ম্যাক্সিমাম +1 করা হয়েছিল।
ইয়েস
ইয়েস ইয়েস। হ্যাঁ
here uh, yes, this will be a limitation to this algorithm.
হ্যাঁ স্যার ওটাই বলছিলাম, ঠিক
Okay.
আছে ঠিক আছে।
আসলে লিমিটেশন বলতে এটা ওটা মানে তোমার হ্যান্ডেল করাই যায়, ওটা নিয়ে কোনো খুব একটা বড় ব্যাপার না। তাহলে তোমার একটু বুঝতে একটু কমপ্লিকেটেড হয়ে যেত ইনিশিয়ালি, ঠিক আছে। নাম্বার অফ টার্মস ইকুয়াল টু ম্যাক্স অফ n1, n2 এটা হবে না সেক্ষেত্রে। তার কারণ
হ্যাঁ
আইডিয়ালি তোমাকে যেটা যদি তুমি করতে চাও সেটা হচ্ছে যে, তো এই যে এখানে যে ম্যাক্সিমাম ডিগ্রি রয়েছে, ঠিক আছে, তো সেই ডিগ্রিটাকে তুমি কনসিডার করো। মানে অ্যাকচুয়ালি কি হয়, in the first polynomial the maximum degree is 9. Okay, so maximum number of terms possible. If you have to suppose you are given a polynomial, forget about this polynomial. So I am giving you one polynomial. Somartha bolcho, right? So
হ্যাঁ
if
স্যার।
I ask you, you are given a polynomial of degree 9. You answer me how many terms are present in the polynomial.
স্যার 10।
No, not necessary.
স্যার 9 থেকে ও সবকটা টার্ম যদি প্রেজেন্ট থাকে
So
তাহলে
যদি না থাকতে পারে,
হ্যাঁ হ্যাঁ মানে হ্যাঁ
degree is still 9, h to the power 9 plus 1. It's a polynomial.
ইয়েস ইয়েস
Its degree is 9. But terms are number of terms equal to 2. Other terms are not there. Means what? Vanished. Means what? Coefficients are 0. Okay. So that is the understanding. That's not a big deal. You can handle this situation. That's not a problem. So if you have a degree, here it is 9. And but not necessarily that here it will be 9 terms in the polynomial. Here also degree is 4. The maximum number of terms could be here 5. But yes, here all the terms are present. It's an exact polynomial. This is okay. So so if you switch, modify this program, incorporating this logic that this computation you are doing in terms of degrees. So max of d1 comma d2, where d1 d2 are degrees of the polynomial 1 and 2 respectively, then it will be fine. সেক্ষেত্রে কি হবে, একটু তোমার কমপ্লেক্সিটিটা বেড়ে যাবে। তার কারণ কি, কেন কি যেগুলো ভ্যানিশিং টার্মস ছিল সেগুলোকেও তোমাকে কম্পিউট করতে হবে। বোঝা গেল? এখানে কিন্তু তুমি কোথাও চেক করছো না ভ্যানিশিং টার্মস, এটা তো ভ্যানিশিং টার্মস এর জন্যও তো আছে। এই বলছি তোমাকে একটা এক্সাম্পল, একটুখানি সময় নিচ্ছি, 1 মিনিট, অ্যাটেন্ডেন্সটাও নিতে হবে। সেটা হচ্ছে যে ধরো এক্স কিউব প্লাস এক্স প্লাস 1, আরেকটা আছে মনে করো x4 মাইনাস এক্স প্লাস 5, এই দুটোকে তুমি অ্যাড করতে চাও, ঠিক আছে। এবার নাও here degree is 2, here degree is 4. So degree is 2, here degree is 4, right? So max of degree 2 and 4, that is equal to 4. তার সঙ্গে একটা add করে দেবে, total 5. So number of terms in the resultant polynomial will be 5 because the degree will be 4 obviously. So 5 vacancies are there. You have to create memory allocation for 5 terms unnecessarily. So as a result, what will happen here, it will be x to the power 4, then here it will be x square. Okay, sorry,
স্যার এক্স কিউব হবে।
so x cube তো নেই, এবারে কোথাও নেই, তাহলে x square, then plus x minus x 0, and here it is 6. So this is 0, it is being computed because these were originally there, x and x terms are there, but x cube was not there in polynomial 1 and polynomial 2. X cube was present, absent. So you don't have to compute for this x cube, this is not at all there, right? So this is the area where your algorithm is unnecessarily computing a value.
ইয়েস স্যার ইয়েস।
Okay, so this is the okay. So yes, this algorithm will have some advantage. It is not computing those unnecessary computations, and yes, it is having some disadvantage. Okay, like the example situation which you have told. Okay, okay, okay. So I think we are done. Now let me take the attendance. If you have any query, it's a very good problem. I like this problem very much, and I hope that all of you will be liking this problem also. আচ্ছা, সৌমার্থ মুস্তাফা স্যারের কাছে চলে যাবে।
প্রেজেন্ট স্যার প্রেজেন্ট স্যার।
সৌমার্থ, সৌমদীপ
প্রেজেন্ট স্যার।
ওকে, আচ্ছা সানি,
প্রেজেন্ট স্যার।
ওকে, সৌমদীপ, সানি, ঠিক আছে, ডবল ডবল নাম বলছি কারণ তোমাদের অ্যাটেন্ডেন্স কম। রিতম মাহাতো নেই, Okay. Tofik Ansari. Shayan Mukherjee.
Present, sir.
Okay. Samrid. Shayok.
প্রেজেন্ট স্যার।
Shankoti Bera. Vivek Agarwal.
প্রেজেন্ট স্যার।
Sangram Chakraborty.
প্রেজেন্ট স্যার।
Suparna.
Present, sir.
Shreya.
Present, sir.
Rohan গঙ্গোপাধ্যায়।
প্রেজেন্ট স্যার। প্রেজেন্ট স্যার।
আচ্ছা, এখন তাহলে ইয়ে নেওয়া যাবে না, শর্ট কুইজ 10 ওটা পরে নিয়ে নেবো, যাদের হয়ে যাচ্ছে ইউ মে লিভ and go to Mustafa's class. সায়নী চক্রবর্তী।
Present, sir.
শুভজিৎ জানা।
Yes, sir. Present. Present, sir.
সাহিল। ওকে। সায়ন্তী, সাহিল অ্যাটেন্ডেন্স গিভেন। সায়ন্তী।
Present, sir.
রোশন। সানি কুমার। রোহিত কুমার সিং। উৎসব। উৎসব দত্ত। এদিকে মাঝে মধ্যে পাওয়া যাচ্ছে না, মাঝে মধ্যে কি হচ্ছে কি জানে। রিয়া কুমারী।
Present, sir.
Your attendance is also very low. Very low. Shivani,
Present, sir.
your attendance is also very low. Rohan Pal. Vikash Tiwari.
প্রেজেন্ট স্যার।
Rohit Kumar. Srijani Chaudhary.
Present, sir.
Your attendance is also very low. Rohit Das.
প্রেজেন্ট স্যার।
Sushmita.
Present, sir.
Rohi.
Present, sir.
Shreshna.
Present, sir.
Your attendance is also very low. Rishik.
Present, sir.
Sayon.
প্রেজেন্ট স্যার।
Sharup.
প্রেজেন্ট স্যার।
Attendance of Sharup is also very low. Vikas.
Present, sir.
Tuhina.
Present, sir.
Improve your attendance.
Present, sir.
Somadip, improve your attendance. So Somadip Banerjee,
Present, sir.
Sagnik,
Present, sir.
Shayok, Samanta,
প্রেজেন্ট স্যার। প্রেজেন্ট স্যার।
Shatarup,
স্যার ইন্দ্রনীল প্রেজেন্ট 91।
Indranil,
প্রেজেন্ট স্যার।
Soham,
Present, sir.
স্যার শতরূপ প্রেজেন্ট।
প্রেজেন্ট স্যার। স্বপ্নিল প্রেজেন্ট।
Sir, Shubham
স্বপ্নিল
present.
প্রেজেন্ট স্যার।
দিয়েছি। Wendri,
Present, sir.
Shubham,
Present, sir.
improve attendance. Siddhartho, Siddhartho, Subrodipto,
Present, sir.
attendance very low. Shivarpon, Shivarpon, okay. Okay, thank you.
স্যার সমৃদ্ধ প্রেজেন্ট।